All right, as we lead into actually factoring polynomials, there's a few things we want to think about. We want to think about the distributive property. If we have this 2 times this binomial, 2 gets multiplied by x, and 2 gets multiplied by 5. So we're going to end up with 2x plus 10. Now, with that in mind, it might be wise, not might, but it's a very good idea. Even though we can say, hey, let's take x times x, let's take x times 5, let's take 2 times x and 2 times 5 using the distributive property, some people say use FOIL. It would be better in the long run if we said, you know what, in this binomial of x plus 2, we're going to take the x and multiply it by both terms in the second binomial. Then we're going to take the 2 from the first binomial and multiply it by both the terms. That shows the 4 different products that we're going to get, and so that's going to be important as we go forward. It'd be nice to look at things this way. So polynomials, remember, they're terms, different terms, and we name the polynomial by the number of terms. This is a trinomial, this is quadratic trinomial, this is a linear binomial, that's a linear monomial, that's a constant monomial. If we keep that in mind, then let's go here. Factors, they're things that we multiply. So therefore, when we say we're going to factor something, then we're going to make it the product of polynomials. Even the number 6, we can make it as the product of 3 times 2, and officially 3 is a constant monomial and 2 is a constant monomial, so it's the product of 2 polynomials, 2 monomials. Now, if we're going to factor this, 2x squared plus 10x, then we're going to find the GCF, the greatest common factor. And that greatest common factor of these two terms would be 2x, because if we were to look at this, we could write this as 2 times x, that's what x squared means, plus 2 times 5 times x. So we can see that the common factor would be that we have a 2x in each of those two terms. So when we say we're going to factor out the greatest common factor is 2x. What binomial would you multiply it by that would take you back to this? Answer, 2x times that quantity would get you this. So it's the product of 2 polynomials. This is a linear monomial, this is a linear binomial. We have factored it because it's 2 things multiplied together to give you this. Alright, factor this using the GCF, the greatest common factor. All of these terms have a 3 as one of their factors, and this has 2 x's multiplied together, 3 x's multiplied, 4 x's multiplied. Therefore, the greatest common factor is a 3 along with an x squared. Now, we need to multiply this times a trinomial so that we get back to that right there. Now, we can look at this as division. 3x to the 4th divided by 3x squared. 3 divided by 3 is 1. X to the 4th divided by x squared is x squared. Therefore, this term right here would be x squared. This term divided by this would be a 4x. And now let's see another way to do this. Instead of division, what I think is simpler is, once we got the greatest common factor of 3x squared, just ask yourself, okay, what do I have to multiply this by right here to get back to the 3x to the 4th? This is 3x squared, 2 x's are being multiplied. I need to multiply by 2 more x's to make it up to 3x to the 4th. I think it's easier to figure out what that term is that I have to multiply this by to get back to the 3x to the 4th instead of really actually doing division. So why did we end up with 4x? Well, 3 times 4 will get us to 12. X squared requires being multiplied by 1 more x to get us up to the x cubed. What term goes here is our final term in the trinomial. I have to multiply 3x squared times some number to get us to 6x squared. Don't need any more x's, just need a 2. There it is, that's in factored form. This monomial times this trinomial, factors, things that are multiplied together. So there it is. This is the factored form of that trinomial. If we look over here, the common factor, 4 goes into both of these, so we can take out a 4. This has 2 a's multiplied together, that only has 1. Oops, let me erase that. So far we have a common factor of 4, and we have 1a that is a factor of both. Both have at least 2 b's being multiplied, so there we go. That's the common factor of both these two terms. Let me just maybe move this guy over a little bit. So now what's left is, what's going to be this term minus this term, that when we multiply this common factor, we'll get back to that. Well, we need another a to get us from a to a squared, and another b to give us from b squared to b cubed. So this must be ab. If we multiply this factor that we took out times ab, we're going to get back to that right there. Now, we have a subtraction sign here. What do we put over yonder? 4 times 3 will get us to the 12. We don't need any more a's, and we don't need any more b's. We're done. This is the factored form of that guy. If we were to multiply this factor times this factor, we'd get back to that right there. Now, one last thing. A very valuable connection that we want to make going forward, and it's what we started this video with. If we take this x times that binomial of x minus 3, plus this 5 times the binomial of x minus 3, what that equals is this. And here's the way we can think about this. This is going to be very important. Let's think of that as our very special binomial. That's our x minus 3. That's our special binomial. How many special binomials do we have? We have 5 of these buggers, plus we have another x of these guys, whatever x is worth. So, how many of these special binomials do we have? We have x of these plus 5 of these. All together, we have x plus 5 of the common binomial. So this is going to be a really important connection as we go forward.